Good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the MyMangrove or the MyMangrove Monthly Discourse, the Malaysian Mangrove Research Alliance and Network Monthly Discourse for the June edition. And today we are so proud, we are so happy, we're so honored, in fact, and humbled to have one of the most prominent soil scientists in Malaysia with us. We have Dr. Vijayanathan from the Forest Research Institute of Malaysia. The best part about working with Dr. Jeyanny is that she has huge interest in mangrove. Not just her, but her team at FRIM, as well as her networks throughout Malaysia and throughout the region and the world, in fact. So a couple of things I need to highlight about Dr. Jeyanny. Dr. Jeyanny is a senior research scientist at FRIM. I think you are heading the soil lab. I assume, Dr. Jeyanny, is that right? Is that correct?
No, we have another officer heading the soil lab.
Oh yeah, Puan Rosita.
Puan Rosita. Yeah,
okay.
I'm a research officer under the same branch.
I see. Okay, that's good to know. So there you go. There's already a strong team there, the lab, the field. And Dr. Jeyanny is the Vice President of the Malaysian Soil Society.
That was the last term. So
okay.
So we had an AGM lately. So I have taken up a much more smaller role this time, Dr. Aldri, because I've just been nominated to become a panelist for the International Technical Panel on Soils for FAO. So I'll be more active in this.
There you go. Actually, I was just trying to trick you to expose that in a new position. There you go. So big role here in the country and as well as at the international platform. And Dr. Jeyanny also recently, this is a must-tell news, she was recently awarded with an international award at a conference. I mean, you just came back recently also from an international conference in India.
In March 2022.
March, so there's an international award for, I think, women in science, something like that. Is that right?
Yes, outstanding woman researcher in soil fertility discipline.
Okay, that alone actually stops me. I mean, I should stop from explaining further, and you have one of the best person to discuss with us today about muddy footprints on tropical mangrove soils. So we know very well, so already a little bit here and there, about how important mangrove soils as the storage area or the space to store carbon. We know mangrove as one of the best, in fact, the best habitat and ecosystem to sequester and to store carbon for many hundreds and thousands and millions of years. And in addition to that, mangrove soil also hosts huge, wide array of diversity of species, including the plants, including the animals, including the microorganisms. So with the condition of being in between land and sea, this is where salt water meets fresh water. So they're salty, they're brackish, can be fresh some of the time. So a lot of things happening on the soil, in the soil of mangrove forests. And there are other things happening on the coastal area as well, including processes like erosion, accretion, and increasing or decreasing level of elevation. And there are processes also like sea level rise happening on the coast. And as you all know, tropical coasts face events like hurricanes, storms, monsoon, like in Malaysia. So a lot of things happening in the mangrove in our country, all around the tropical belt. And one of the key physical components that we have to take care of, that we have to pay attention to, would be the mangrove soil. So to share with us her knowledge, her experience, not just her, the whole team of studying, I think about 20 years, maybe more, maybe less, of experience working in the mangrove. We will hear today, about 45 to 1 hour time, we will hear from Dr. Jeyanny representing FRIM and the team on the research updates, findings, and perhaps opening some opportunity for all of you attending here through Zoom and through YouTube for more collaborations. As whispered by Dr. Jeyanny also, studies on soil would require collaboration with other disciplines, sub-discipline, and not just ecologists, but we need chemists, we need physicists, scientists on microorganisms, for example, and of course social scientists and lawyers too, to bridge all of this information into policy. So without further ado, let's hear from Dr. Vijayanathan. Dr. Jeyanny, you have the floor, and you may actually add some information that we would require to know. And don't forget to also let us know your contact details at the end or maybe in the beginning for to open up opportunities for more communication and collaboration. So the screen is yours. And thank you again for accepting our invitation.
Yes, thank you, Dr. Aldri. You have, made me a celebrity through that introduction, actually. So I'm just a normal soil scientist in FRIM. It's just that we work in many different areas. I don't want to add up anything that you have, which you have introduced. Today, I would also like to thank you as well as CIMB Foundation for inviting us, representative from Forest Research Institute of Malaysia, to share some of the insights on research that we have actually done, for the past more than 17 years, Dr. Aldri, I think since 2005, 2006. So allow me to share my slides. Okay, is everybody able to see my slides?
Yeah, can see.
Okay,
yes,
thank
you. But you may want to start from the first and put it on the slide presentation mode. Yeah.
Okay.
Excellent. All right.
Okay. All right. All right. Very good. So, good afternoon to everyone who is joining this talk from far and near. Here in KL, I think it's raining on my side of the side. So, ladies and gentlemen, I hope all of you all are fine today. I would like to introduce myself, that I'm Jeyanny Vijayanathan, currently attached with the Forest Research Institute of Malaysia. I've been working here for the past 17 years, mainly on soil science research. Excuse me. I do work on soil chemistry, fertility, soil profile, rehabilitation, conservation, and many other disciplines, as well as research related to soil. So today, please walk with me, take a journey with me on my presentation, Muddy Footprints on Tropical Mangrove Soils. Just like the first slide shows you, this is how deep we get. In fact, we can get much more deeper, Dr. Aldri. Sometimes it's almost to our waistline when we want to go into this very fragile as well as vulnerable ecosystem in order to collect our soil samples for us to do our research. So, ladies and gentlemen, this is just an overview of what we have in our forest. I have to say thank you to Dr. Hamdan Omar that he has given this very beautiful figure on what are the types of forests that we have in Malaysia, mainly montane in the highlands. Then when you come down, you have your lowland dipterocarps, your peat swamps, and of course your coastal mangroves, which is the current barrier against the land as well as the sea. So we are also fortunate that at least 58% of our land is complete or distributed with forests. Of course, with the recent campaign by our ministry level, Kementerian Tenaga Sumber Asli, they are into this 100 million tree planting. I'm sure many has also gone into mangrove planting in order to protect and conserve our coastline. So this is a very great effort, and I hope that everyone who is listening into this talk, please visit this link in order to find out more. So on my right hand side, you can see that this is one of the oldest Larut Matang Forest Reserve, which is sustainably managed in Perak. This was I think established in the early 1900s, maybe 1905, 1906, and it's still standing there, giving us, providing us all the very niche ecosystems that we need in order to protect our coastline. So, ladies and gentlemen, mainly our status of mangrove in 2017 stands about 629,000 hectares. And out of this, in Peninsular Malaysia alone, the biggest chunk is in Perak, about 44,000 hectares, and in Johor, about 26,000 hectares. And this report, which was published in 2020, one of the reports, it also cited that there's an average rate of change from 1990 to 2017. It's about 793 hectares are being used. There's a land use change there, either by development or any other industrial sources. So this is where we stand, where our coastline are degrading, and at the same time, we have to be more alert and more aware on how we can actually conserve these areas. Even in the recent news, we have seen that almost 425 kilometers of Malaysia's coastline has been affected by erosions. Some of them are man-made, some of them are natural. So we have to look into science and research how further that we can actually improve in order to protect our coastlines from coastal erosion. So we know that mangrove ecosystem gives us a variety of what they say uses or functions, mainly in the assistance of stopping natural disasters, okay, your thunderstorms, your sea level rise, and then it also helps in pollution mitigation, remediation. And of course, mainly now we talk about carbon sequestration, where mangrove house one of the biggest value of carbon stocks in its above ground biomass as well as in soils. Besides that, it provides a lot of other functions such as habitat for marine biodiversity, for aquaculture industries, fisheries, as well as for cottage industries. So just to share with you some of our experience from the start, how did we get involved with mangroves? So it all started with the tsunami. I'm sure many of you remember what happened in year 2004 when the Indian Ocean tsunami and earthquake occurred. So it affected many of our coastlines, mainly in Penang and Kedah, you can see. And this was the time, I think it happened on the 26th December. And on the 25th of December, I was actually on a jet ski in the Penang beaches. So I guess I missed it by one day. So the next day I was in the hotel and I could actually feel the earthquake, which devastated the coastlines of Penang and Kedah. So since that, our government has made very proactive action in order to spearhead initiatives to restore and conserve coastline mangroves. So FRIM was actually entrusted to chair the Research and Development Committee whereby funds were dispersed in order to do R&D related to this theme to restore and conserve. So starting in 2005, that is when the soil management team got involved in the measurements of coastal erosion in a small plot in Sungai Haji Durrani Sungai Besar in Selangor. And some of the key milestones was that with our involvement not only in Sungai Besar but also in other areas in Peninsular Malaysia, we were able to publish a book on penanaman bakau dan spesies sesuai di pesisiran pantai negara, penilaian tanah, in 2010. And then we had a much more recent book, which was the muddy substrates of Malaysian coast. So if you don't have this book, I suggest those students or even scientists who are working on soil-related matters in mangroves, please get it from our secretariat in FRIM, or you can drop me an email and I can actually direct you to the right person whom you can get the book from. So until now, from 2005, I joined FRIM in 2005, and until now, my work has always been in mangroves. Besides mangroves, even other ecosystems such as lowland, highland, as well as peat swamps. So what are coastal soils? Many of you will be wondering, what is coastal soils actually? Basically, they are divided into two types. So we have the sandy beaches. This is mainly in the East Coast. You have a single grain mineral, which is your sand. It is quite porous. And then you have your muddy sediments, which is mainly on the West Coast. So soils which actually support mangrove species is a mixture of marine clay, where it can be of different structures. And why soils in mangroves are so important? They actually support life. You can see the pictures here. The Pakcik there is collecting some cockles and shells. This is what they do for living. They collect and they sell it. And then it's also important for aquaculture. It is a breeding ground for fish, as well as crustaceans and mollusks. And of course, the bigger picture would be how soils are actually supporting various vegetation here, right from the seaward, which is your api-api, avicennias, your sonoraceae, your bakau, rhizophoras, your brugueras, xylocarpus, and many more. So these are some of the type of features that we get from the soils that our team has actually researched, you see. So most of the time when we go towards the sea here, all right, this is the type of soil that we get. It is called liquid mud. It is structureless. It's mixed with water. It is sometimes just a material of silt and clay. And then this is the profile that we call as C. In soil science, we have different profiles. So C stands for parent material. So this is usually the parent material. And then we have another profile which is called A. Okay, your A would be your topsoil, where it could be a combination of humus from the vegetation which has actually fallen on the soil surface with the mineral layer. So that would be your topsoil enriched with humus. And then you have your subsoil, which is B. So B is predominantly the mixture of the parent material, which is actively forming structures, or even forming soil, firm soil. So the first picture shows you liquid mud. The second picture shows you the massive soil. Okay, and the third one and the fourth one shows you a bit of structure where it is of a mixture of shells And the fourth one is with the hemic or separate materials. In layman term, we call it as organic material. So these organic materials are usually divided into three types. It's either your fibric, hemic, or separate. So fibric stands for organic matter which has not decomposed fully. Your hemic material is partially decomposed, and your separate material is fully decomposed. So these features are very common in peat swamps when you go sampling there, and of course you also have it in coastal mangrove soils. So firm one would be something like this at the subsoil. So this is how we have actually put in the profile in one of the books that has been published before this in 2015. So you can see that different vegetations fall under different types of soil here. So the first layer, which is facing the seaward, would be your Avicennias or your api-api, because they have these new metaphors as their roots. They only need a little bit of substrate to grow. And so when these new metaphors, they will start consolidating and stabilizing the soil by their proliferation of roots. And then you have your sonarishas as well as your rhizophoras. Of course, your rhizophoras, they have still roots, and they need a much more firmer soil compared to Avicennia. So that is why when you are planting mangroves, it is very important which layer are you going to plant, so that Avicennia would actually will be the guard, the guard for the bakau to survive, the Rhizophora species. So Rhizophora, I'm sure all of you all know there's bakau api, and then there's bakau minyak, and then there's bakau kurap, and then another one would be Rhizophora stylosa, which is rarely found in Malaysia. So the most common one is minyak and kurap. Then you have your Bruguera species. They have these knee roots, so they are more established. Their anatomy of roots are much more established. So they would need much more firmer soil, like what you can see here. So this is just to share with you what type of soil can house what type of vegetation when we are doing planting in mangrove area. So here I'm going to share with you what has been our experience on soil research in mangroves alone. Of course, I think the first assignment that we got was in year 2005. We were summoned to go to this area in Sungai Haji Durrani, where it was going through drastic erosion. Okay, so why was that? Because of the erosion, they placed a geotube. It is like a geotextile material to halt the very heavy currents of wave from coming and eroding the coastline that we have here, right? And then we started putting in our erosion pins here and measuring. So we did this for quite some times. We also took soil profile materials, and during that time, it was all liquid mud, It was very, very difficult to go in. You need to use this. You see this yellow tray here that I've shown you. This is what you use as, to move into the soil. So I have to say thank you to our soil management staff, who was fearless in doing research in many, many different ecosystems that we, have encountered. There was always, yes, we can do, because they understood the importance of research. So here I have just shown you, what was the, results that we got just for a year on the eroded materials that we got from the placement of area with geotube and without geotube. So here again, when the soil was quite structureless in 2009, you can see here with the placement of geotube, it actually allowed regeneration to happen just opposite the geotube. So it has formed good structure. Of course, it is a yin and yang situation. When you have a geotube, it kind of like stops the erosion here, but all the sediments gets, collected or accumulated here or accreted here. So just to share with you, this is how it looks like compared to 2009. Now you have quite, established mud flats, which has become a plot for, regenerated species of Avicennias and other mangrove species. So secondly, we were also involved on soil remediation and soil pollution work, whereby in Tanjung Piai, one of our colleague, Tuan Rosita, we collected sample where we call it as Tanah Sesai. This was brought back from the area where it was assumed that it was causing some mangrove mortality here, the debris from the sea, and went through pyrolysis and started using it as a soil amendment in testing mangrove seedlings. So you can see here some of the other work that we did in Kedah, in Perlis, these were all these stills. Shows that some of the trees which did not survive because we didn't understand the signs of this liquid mud, this firm, moderate structure, and so on. And this picture shows you the content of iron within the mangrove soil, which can also hamper the growth of mangroves if it's in large quantity. In this table, which has been taken from the same book, we show you the profile of the Matang mangrove forest. We collected soil up to 100 cm. You can see how deep is it. So some of the key findings is that the area here in Matang has about, a good combination and proportion of clay and silt, about 20 to 50% for clay and silt about 10 to 30%. It has a moderate soil structure. And the salinity ranges from 6 to 9 millisiemens per cm with the pH 5.5 to 7.5. So most of the time, the pH in mangrove areas are either neutral, near neutral, or slightly alkaline. So when the pH drops below neutral, which is about 6 or even 5.5, that actually helps in the transformation of nutrients as well as the activity of microbes in the soil. Another work that we did in 2018 was actually trying to assess back the area. Remember, I was telling you the one with geotube and without geotube on the soil quality. We wanted to look at how different was the soil in an area which already had the vegetation, the old growth vegetation, and then another area which was a mud flat which turned into seedlings which had newly regenerating seedlings. So from here, this piece of work was actually assisted by some of very good UPM students as well as from UITM. They did this as one of their FYP, final year project work, and it's also been published. Some of the key findings was that we were able to use geospatial modeling in order to look at the soil quality of these two areas. What was that we found was that the soil salinity and pH were significantly different in the regenerating site. It was much more lower compared to the natural all-growth vegetation. And of course, since despite the fact that these both locations are quite near, but they house different types of soil due to the effects of geotube, it is important to have a site-specific management of mangrove forests. Okay, another study that we looked at was that, okay, we did soil profiling, we looked at the chemical values, we looked at the physical values, and then we started to become more adventurous. So we said, why not we look at these soil biological features? Let's look at the bacteria there. So we wrote a paper with our co-workers from the genetic lab. as well as the soil scientists, on looking at the bacterial communities which were there in the newly regenerated forests as well as the old growth one. And some of the key findings that we highlighted was that soil pH, organic carbon and organic matter as well as nitrogen was significantly different in these two types of plots that we had. Bear in mind that for mangroves, phosphorus and nitrogen play key, important nutrients for the growth of mangroves. And then these sediments were dominated by the proteobacteria and the firmicutes group. Of course, the intensity of groups differed with soil depth. You had more bacteria at the 0 to 15 cm depth compared to 15 to 30 cm depth. And of course, the rehabilitation of mud flats, we believe that also led to positive colonization of these bacteria which were there. Moving on, we did a similar work in Tanjung Piai. This was mainly to look at more of how the values of bacteria change in a polluted area that we assumed that it was polluted and another area which was non-polluted, because the one in Tanjung Piai, there were always reports saying that there was a lot of pollution coming in from the seaward. Okay, so the results that we got was that, so it was quite hard to go into this area because we had to be there as early as 7 a.m. Just so that we don't get drowned. The water was coming in so fast. So we also had to collect our samples, put it into a liquid nitrogen tank and transport it to FRIM in order for us to do this work. So mainly the sediments dominated proteobacteria again, but a different type of another bacteria, which is chloroflexin. The mud flats, excuse me, had the highest OTUs. And then we thought that, yes, we know that the bacteria are there. So what? What does it mean to us? So I think this paper was very important to give us a direction on to look at functional groups, because now everyone is using NGS, so it is time for us to use these types of technologies that can actually give us more information. What are the bacteria are controlling the nutrient transfers, the remediation processes, vegetation productivity, and many other functions. Okay. So this is my current work which is going on. So this was actually inspired when I went for a boat trip to look at what do you call it, the fireflies. This is me with my son. So we were just going in the boat. We were so happy looking at that pokok berembang lighting up like a Christmas tree. Then we found this debris. I took this picture. It was just floating along our boat as well. Then I thought, my gosh, there's so much of this in the river. We got to do something about it. Can't we even, think of something that to make sure that the river is clean, as well as it can actually, we can remove it and use it for something else in order that the river is clean, it reduces the pollution. So that is how we came up with this idea of transforming forestry waste into wealth. So we are testing some of the organic materials from forestry waste, including this that you see there. We go through the same process, the pyrolysis, and we will be testing soon to see whether it helps in mangrove productivity and vitality. So this was our recent work with our NGO, the Malaysian Society of Soil Science, where many institutes came together, such as the MPKS, the LUAS, UPM, FRIM, MARDI, and many other agencies who came in order to engage the community on the awareness of keeping the rivers clean and how we can actually move this material. How we can actually transform this material of something which is useful. So, so far, those are the work the soil management team has done so far. There are also many others which have not have enough time to highlight here, not only from the soil team, from the natural products division, from the forestry division, the GIS part and all that. But if you need to have more, work being seen for your literature, you can always access some of our books as well as our journals in FRIM. So some of the research gaps that I think that it's still needed in mangrove soils is how can we elucidate more on the role of soil biodiversity, blue carbon, how can we look at how it plays an important role in reporting carbon for the national reporting. When you're planting your mangroves, you spend so much of money on the clearing of the area, the seedlings, the manpower and all that. So it is very important to look at how does soil nutrients or even the soil profile is related to the mangrove vitality in order for us to allow the tree grow to continue and to form that precious ecosystem coastal barrier that we all need, which is currently degrading and eroding. So of course, we can also look at the bioprospecting of certain bacteria for biofertilizers and biodegradation. We need to put in the value of dollars and cents to the ecosystem that which actually we are dependent of. It's not that mangrove needs us, we need the mangroves rather than mangroves needs us. And how can it be put into this REDD plus scheme? And everyone is talking about sustainability. We also have to look at sustainability and how this can be moved into something of a circular economy. So these are the questions which is running in my mind, or if there are any takers, please go ahead and explore more what you can do to protect these mangroves. So here are some of the achievements that we have, got from the, books that we have published, the proceedings, reports, also the FYP theses that has been submitted. Some of the papers are in this link. If you want to, you can go in and download freely. The papers that I showed you, most of them are freely available from the Journal of Tropical Forest Science. So I also take this opportunity, if you want to write anything any subject related to forestry, please send your manuscripts to our FRIM in-house journal, JTFS. So in summary, mangroves is a fragile yet resilient ecosystem with mutual benefits. We need the mangroves as much as, mangroves also needs us to conserve it. What are the opportunities and challenges that we can look at is that let's not reinvent the wheel, do back what our ancestors has done, but let's try to embrace new technology like your AI, your GIS and whatnot to serve all the other, not only soil, all disciplines of research and applications alike. It is very important, like what Dr. Aldri has said, no man is an island. Try to form synergistic partnerships with different types of expertise and discipline in order to have a successful research that benefits everybody. And keep in mind that this integration of models and UN SDGs are the new paradigms that we have to consider for our future research and application. So my slide is freezing. Just give me a moment for a while. Okay. So I think that was my, I have 2 more slides to go. I would like to acknowledge the Director General of FRIM and the Division Director for constantly supporting us in our research that we are doing, as well as the approvals that we get in order to go into our fieldwork and our publication. MyMangrove Committee, Dr. Aldri and the CIMB Foundation, fundings from the Ministry, CATSA, and also other agencies for our community projects. practical trainees and students. You are the next generation of scientists. And if you want to do your LI here, Latihan Industry, you're most welcome to come and visit FRIM. Our very effective and resilient soil management staffs, FRIM colleagues who have come in very different disciplines in order to give us feedback, such as on genetic work, on GIS work and all that. So there's ample of science for everyone to discover, just like as how the mangrove swamp has so many roots and so many different types of roots that I have, shared with you. So these pictures are just to show you all, we are all very happy doing work in the mangrove. We enjoy it very much, and we hope that we can create a difference in order for the advancement of science. So this is another picture showing you me visiting Tanjung Piai in 2009. Then after so many years, I visited again in 2017. That whole, place, the platform there has been eroded. It's no more there, left with this alone. I would also like to share that some of the papers that we published was able to get best paper award in year 2019 or and 2020, if I'm not mistaken. I was able to moderate some important, dialogues with FAO during our MSSS Golden Jubilee about last year on soil salinity. Last year, the theme of FAO was soil salinities, which is saline soils, very related to mangrove soils. This year, it's on soil nutrition, which is soils where food begins. Also had the opportunity to share some of the, challenges towards ecological resilience with the collaborative effort of UPM, UKM, UTM, and many other institutes with Dr. Natra. So with that, I would like to end my presentation. Thank you.
Thank you very much, Dr. Jeyanny. I saw Dr. Diva just now commented saying you took us through your journey. Yeah? Basically, from the beginning, basically basic information about mangrove soil 101 to the application side 303, 404. Thank you very much. Thank you very much for all the input. A tremendous amount of information there and studies as well. And I saw Dr. Wan Rashida's picture at the end there. Of course, she played instrumental role.
Yes, she was our boss. When we started writing the book, she was very passionate about us, doing all this work in order for it to be documented in that book. Yeah,
I remember her like running all around country, highlighting the work and requesting for more research to be carried out. And and I think the legacy left at FRIM, as well as some of the knowledge published in books, papers. So that's very important for us. A huge, I reckon baselines. We pretty much have very good baseline already on soil studies.
yes.
And you did mention some of the gaps still, but yeah, of course, that's why that's how science evolve anyway. It's always a renewal. Renewing understandings, renewing findings, and updating for better protection, for better conservation, better management too. And yes, I like your points earlier of synergy in between scientists, in between of different disciplines, of course. And some of the gaps that you highlighted earlier also did mention about the use of technology. So AI, yes, I think this is where the younger generation could also help in assisting us. And on the physical scientific part, I reckon hydrology is a very important component as well. We may know a lot of the physical characteristics on the soil structure, but then there are issues here about the hydrology when the changes happening on land would have some effect on the vitality. I like that use of terms as well. The vitality of mangrove soil that directly affect the sustainability or the viability of the habitat and ecosystem.
Yes.
So thank you very much. Blue carbon, you did mention about blue carbon in the gap in the knowledge gap section. I agree. because this is key. This is key in reporting our national determined contribution. Yeah? Fairly brief in our recent report, but then this is very much needed to link to your next point of PAS, REDD, if needed to be enhanced, yeah, for better control and better management again. All right, so we have actually a few questions, and I mean, a remarkable group of participants we have today actually. So thank you very much everyone for joining. Dr. Jeyanny earlier did highlight on the use of GeoTube and how successful recovery of a certain patches on the west coast of Peninsular Malaysia. So Dr. Allison extended that point by asking, from a soils perspective, how do we measure erosion or determine its extent? I mean, can you briefly respond to that, Dr. Jeyanny?
Okay, so what we did was that we used the conventional ways of, putting in erosion pins, but we were only, I think the method that we used was not very foolproof, because some of the areas which we put in the erosion pin also, got eroded. So we couldn't, locate the pins. We think that it will be good to have people from NARIM, or who can have some proper measurements on this. Since that was the only erosion pin study that we did, we didn't move further. But it's good to look at other types of, maybe using a laser measurement, something like that, Dr. Aldri, in order to estimate the erosion level in the coastal area.
Thank you, Doctor. Sorry, my environment is a little bit noisy now.
Okay.
So I don't have a background in soil science. Maybe can you explain a little bit more how erosion pin works?
So usually what happens is that we get these PVC pipes, we get these PVC pipes, we cut it into different lengths. Then what we will do is that we will decide what would be based on the site specific area. We will decide what is the length of the erosion pin should be from the CH to the inland, to the land, From there, then we will make periodic measurements in order to see how much of the area of soil has eroded from the erosion pin to the sealand. That's how we did it last time, Madison.
All right, thanks a lot, Doctor. Thank you.
Welcome.
Thank you very much, listen for the question. And if I may add just a little bit, I also heard some studies carried out using coastal vulnerability index. I reckon that also should include these physical changes, aerial changes, aerial analysis of the changes, as well as considering other factors like biodiversity loss, not the plant alone, of course the marine life, the fauna, all the gastropods, and marine dependency, marine organisms and terrestrial organisms dependency on these habitats and ecosystem also, and not forgetting the socio-economic components. So yes. I reckon in addition to the physical analysis, this vulnerability index could be used, and I think it's still very patchy also. It's been done, I think, for Selangor Coast, for Pahang Coast, I think. And yeah, you did mention about NARIM's involvement. Yes,
yes.
They have very significant contributions also for this understanding of our coastal environment. And they also actually contributed to publications of I think coastal some report. I think it's already in the 3rd edition of on the coastal status of our coastline. Yeah, the status of our coastline. Sorry about that. Yeah. Yes, we can delve further into that later, Alison. Thank you very much. And Mr. No Azmi asked about the wave breaker. Does it have advantage on to secure our shoreline? I think you briefly showed Tanjung Piai. The globe, if I'm not mistaken, the globe was shifted a little bit. It's not the original location, right? Yeah,
yes,
but then that would be the one of the prominent example. To respond to this question, Jeyanny.
So okay, when wave breakers, from the literature as well as what we have experienced, they seem to only provide a temporary, solution. Mr. Azmi. So so far, even the geotubes that they fixed at the Sungai Besar and all that, it burst, if I'm not mistaken. It burst, and all the materials inside there were washed off. So these things can help in temporary solutions, but in long term, I think the DID may have better, made out of blocks, or concrete type of wave breakers, which can actually help to secure the shoreline.
Yeah, that's right. Yeah, I mean, I remember you're right. Some instances in Tanjung Piai where I mean, the erosion rate, I mean, wave rate, the boat, the ship traffic in that part of Strait of Malacca is heavy, and the geotube burst, and the sand filling up the geotube actually kills
Yes.
some portion of the mangrove. So it added to the threats, or to the stress the mangrove had, and they ended up building up that wave breaker that we see now. So I'm not sure of any updates, or any research after that, but it would be nice also. Maybe we'll be in contact with Perbadanan Taman Negara Johor Parks Corporation to maybe hear of the updates. I will hopefully get in touch with them soon, or maybe some of you would help with that also. Yeah.
Dr. Adri, just to add in, we can't also stop sea level rise. It is way beyond our control.
Yeah.
So that is also one major reasons of coastal erosions. So sometimes, no matter what wave breaker that you fix, if the sea levels are rising, sometimes it's quite helpless there as well.
Yeah, that's right. Yeah, I mean, I like that you actually pasted that minister's face just now, the article.
I got it from you.
Yeah, that came up like last week, I think, right? Of the highlight. And yes, in that article, if you remember, there are already, I mean, like cautiousness within the government of having also to think of an option, which is retreating our communities from or shifting, relocation or translocating the communities from coastal. That would be, of course, has to be done very, in very systematic fashion, in very, like proper. Otherwise, it will create havoc also. But yes, sea level rise is happening. I mean, I don't only put sea level rise as a natural disturbance. It's actually triggered by all of our actions on this while,
Yes.
right? So yeah, it's a vicious cycle, I would call, and impacting us. Yeah. So a lot of control, a lot of mitigation and adaptation in that sense, to be put in our plans. Yeah. So I hope that answers Mr. Noazmi's question. And yes, all in all, they look as a very temporary measures. So more actions, more stronger action, or a bigger scale actions must be taken. Yeah, in addition to these small mitigation actions. And Miss Corinne Wu, this is a little bit technical about planting, I reckon. The question is replanting replanting mangrove, what is the suitable distancing between seedlings? Would planted mangrove function better as windbreakers when planted in straight rows or at random? So, do you want to answer that?
I'll try, Dr. Adri, but I think I will need your help to add in later. So I think usually they will try to plant between about 80 cm to 1 meters apart. That's what I see from my experience. If you have I don't know if there has been any research done on the distance, suitable distance, which is successful for mangrove rehabilitation. But your second question, you're asking whether it's better to plant it in straight rows or at random. So let's look back at the natural ecosystem. Nobody planted them in straight rows, you see. So they were all were regenerating on their own. So I think this may not be a very crucial thing for us to think. But if you want to make it look pretty in terms of aesthetic features, when you want to take photos and all that, then you can plant it any rows that you want to, Miss Corinne.
Yeah, if I can add on to that, the best way to tackle this issue is to understand the natural setting of the habitat. So I reckon, and then this is where we need to protect more. We need to conserve a more original or natural mangrove habitat. So we know the natural situation, and what's important here, because I mean this is. I like your point earlier, Dr. Jeyanny. You say mangrove. We need mangrove actually. So we have to learn. We should understand how the dependency on these resources and how they survive.
Yes, correct.
Naturally,
You
right?
know,
So
we
to
seem to
help.
think that we are the heroes, that we need to, keep them. But actually, it's the other way around.
Yeah.
Without them, we would be in deep disasters.
Correct. So for that, I mean, to the best way to do restoration or to carry out restoration activities is to first understand the habitat. If we talk about conservation or protection, the first step would be to keep whatever we have left. So that will explain or help our next step in helping or assisting the natural environment. So in this case, what we need to understand is natural recruitment of seedlings. So as correctly pointed by Dr. Jeyanny earlier, there are zones like from the coast, from the ocean to the land, is either on the coastal belt or along the estuary. So we need to understand that particular locality. So within mangrove alone, there are zones. There are I mean, like if you walk about 100 meters or 300 meters, you will see totally different settings of soil, of plants growing on it. So this is the first step that we need to learn or to understand when we plan to do restoration activity. So it's not just about planting. So don't straight away think of planting.
Correct.
We first need to understand the
nature of it.
The particular location. If it's disturbed, we should know why. We have to know why it was disturbed in the first place. Because, for example, if the supply of fresh water, for example, is cut off, so we have to rectify that first. And then if changes in elevation, for example, subsidence or elevation, that will provide changes to our plan. It should be a plan B or plan C in restoring. So there you go. I think it's a little bit complicated, Corinne. I'm sorry, but this is no straight answer for that.
Yes,
But
there's
then,
no straight or fast rule. Even the slide which I showed you on the, if you remember those EC values for Matang mangroves, it may differ in a different area. Bear in mind that the threshold of mangrove species are different according to species. So we have to understand that as well.
Exactly. Yeah, that's right. So I mean, we have to consider also the like we have mentioned earlier, the nutrients in the soil, the water table, hydrology regime, tides, all of that. But then, just slightly closer to your question, the best would be try to be as random as possible, because that's how nature works.
Yes.
If you know on how, like for example, Avicennia seedlings fall, and they tend to be, I mean, they're prone to be buoyant and to be dispersed further compared to rhizophoras. For example, rhizophora will go straight, and babies will grow around their parent and waiting for the parents to gracefully die before they can have the opportunity to grow. So this is where, I mean, look at adjacent areas of that particular spot that you are targeting, and look at how the setting in the nature environment. And always remember, this is, I think, another key point relating to Dr. Jeyanny's talk as well as your question, is when you plant 1,000, in a small area expecting to become a forest in 30 years. So you cannot expect that 1,000 to be an adult tree, right? So there will be transactions, meaning natural recruitment coming in and planted one, perhaps a giveaway for the survival of the fetus. So I would reckon the more important target here is not the numbers of seedling being planted, and not the design of where and how to be planted, but it is more of us planning on how that area will be covered by canopy in the specified or targeted time frame. So there you go. I think, Corinne, if you want, we can have like a further detailed discussion later with I think, yeah, I mean, many I like you, Corinne, and Dr. Jeyanny also have been involved. And many of us today, I think, out of this large group of participants today, all of us have been part of some kind of effort of mangrove restoration. So yeah, there are a lot to learn, and I reckon, Dr. Jeyanny, also maybe we can have some very powerful publications together with the team to address restoration efforts. Maybe do's and don'ts would be a very basic information for Malaysia. Of course, there are some examples all throughout the world already, but yeah, particularly for Malaysia, I think FRIM has enough knowledge, and many of us at universities around Malaysia also have some kind of significant contributions to that. Yeah. And yeah, thank you again, Corinne. And your second question: will there be a recorded video? As we speak now, actually, it is live on YouTube, so it will. It will remain there. And this is where I thank all the speakers very much for their contribution, because this is recorded and it is a free lecture, and this is actually a very expensive knowledge. So that's why I'm really indebted to all of our MyMangrove speakers, from Dr. Hamdan in January until Dr. Jeyanny in June, and hopefully until Dr. Hazlin in November. So there you go. So keep in touch and keep checking our MyMangrove Facebook group and MyMangrove YouTube channel. Yeah. Thanks, Corinne. And then Diva, okay, from Dr. Diva, does the erosion pin function to measure surface elevation change? Oh yeah, I mean,
not exactly, Dr. Deva. We just measure the area of erosion, but we do not use it to do the surface elevation change. Yeah.
I hope that answers that. Yeah, so I think there are other technical steps and methods also to address that, and I think this is very important also, because I myself have like very brief experience on studying elevation change on the ground, as well as using these desktop techniques, right? So it should be a mix or a hybrid of both. Yeah. From Esther from Sabah Forestry Department. Oh, we have participants from Sabah, and I saw Dr. Joseph Tanga also is joining us from all the way from KK. So may I ask if you and your team have ever conducted any soil carbon sampling in mangrove area? If yes, what is the soil sampling point depth? Yeah, I saw there's 1.2, I think, some of the areas. You want to delve that further?
Sure. Okay, thank you for the question, Ms. Esther. So usually, yes, I do sampling for soil carbon in mangrove. And trust me, it's not easy, because the deeper you go, the soil turns into liquid mud. Okay, it's very difficult to collect that firm type of soil for you to do the analysis and such. But of course, we try to use some innovative method in order to do sampling. Usually, most of my work, besides for the genetic, for soil profiling, we would follow the standard of 1.2 meters. We will dig in the soil at least up to 1.2 meters, Miss Esther.
Yeah, that's right. So it depends most of the time, I think. Some of them looking at the first top 30 centimeters, and some of the studies. I reckon for the blue carbon analysis, it will require at least 1 meter depth. And as I mean, from my little experience working with Dr. Jeyanny and other soil scientists, within the mangrove group, mangrove groups, I mean, I was told like within one plot, if you take like maybe 3 samples, though all 3 could like provide like different range of information. So there you go. That's a very important point to actually that tells us to do more research, to do more sampling, and to get better understanding of an area for blue carbon in particular. Yeah, and perhaps I reckon it could also give answer to other parameters as well. So more things to be done there. So Dr. Jeyanny cannot do alone. So yeah, but Esther, I hope you can also share some of your work or maybe findings.
Yeah, we can collaborate, Esther, if you need further assistance. Drop me a line or something. No?
Or maybe Esther, if you want to turn on your mic and video to share maybe your experience in Sabah, how about that? Is that okay with you? Or is she still here? Okay, it's okay. As we wait for Esther, maybe next is May. May Ng from Top Glove. For layperson, is our mangrove seedling and planting project suitable or right direction of helping nature? Yeah, there you go, Dr. Jeyanny.
Hi, Miss May. Nice to have you in this, in this seminar. Anyway, good job. Top Glove is involved in, going towards these nature-based solutions on planting mangroves. I think it's important. What you're doing is important, I think, of course, it's suitable, right direction. But I just a word of caution, just like how we went planting and how we had to go and do assessment in areas where the mangroves did not survive, trying to make sure that you have a foolproof plan where once you plant, you also have a plan to maintain that whatever that you have planted. You need to see that continuity and the sustainability of the plants that you have planted there. So periodic maybe measurements or monitoring is necessary at least the first few months in order to make sure that the saplings that you have planted grow well and establish well.
Yeah, very correct, very true.
The thing is, Dr. Aldri, we end up planting and we don't think about the afterthought of how we are going to maintain those plants, not only in mangrove ecosystems, I'm talking about in other ecosystems as well. So even when you start to think about planting, have a full-fledged plan on how you're going to monitor and maintain this plot in order for it to really become a good plot. That is very important.
Yes. Yeah, I agree. I totally agree to respond from Dr. Jeyanny. Corporate organization, especially like Top Glove and other corporate and private companies, yes, they have this obligation. I think it's no longer voluntary. It should be it should be a compulsory thing to contribute through CSR or through ESG. And these contributions must be comprehensive, must be properly done. Like pointed out by Dr. Jeyanny, I reckon it shouldn't be a one-off thing. Like for example, gathering people, targeting this area. Okay, just plant. Okay, let's set a record of 1 million tree in 1 hour. No, don't do that. I mean, this is not an Olympics. This is not a championship. This is restoring nature. Imagine, so nature has its own way of surviving, of doing its business. But then if we want to help, we have to learn from them first. We have to learn their needs if need be. But then by knowing that, I like Dr. Jeyanny's point again. I concur with that, meaning not just planting it on that particular day, taking selfies, taking picture, going on the news, going on social media, but the next day, please set a plan to see if they really survive, if they are still intact, if they are growing, if they are competing with each other. Are they inviting in crabs, mollusks, bivalves to compensate or to live a happy life within an ecosystem. So habitat is home, but ecosystem is the interaction in between them, creatures, and physical environment as well. So this is why you may be confused when we interchangeably use habitat and ecosystem. So and then ultimately is to sustain or to maintain that environment and to let this physical habitat like mangrove habitat to either expand, yeah, or if they retreat because of erosion, then other actions would have to take place. So these are some of the angles that corporate organizations like Top Glove can look at. Meaning, if you noted of my points, it's not just thinking of acquiring or purchasing seedlings to be planted or to gather people to buy food for them or to get to print t-shirt or whatnot, but you have to take a large step back of understanding the area, meaning learning about it. So to learn about it, to do research about it, this is where all of us here at MyMangrove, all throughout the country, from Langkawi to Perlis to Johor to Sabah, all of us are all around the country to actually provide that help and to collaborate with local communities, with corporate agencies, corporate companies, government agencies. So, I mean, we are here, and I know many of them now all throughout the country that would want to be part of this engagement. Yeah. So I hope that answers your question, May. Do you want to
thank you.
say something?
Right. Yeah, I would love to. Yeah, there's a lot of insight that you have shared and all that. Like I said, so we want, or rather I represent my company to say that we are laymen because we are not from the forestry. We are no scientists. We are not researchers like you guys. So we just want to make sure that whatever we do, yes, of course, there's some form of continuity from a corporate standpoint. Our main core of business is not the environment, but we would like to contribute as a corporate citizen, a responsible one. We would like to contribute, but because of the lack of knowledge, we sometimes seek professional help. Professional help from you guys. You see, because if you give us a whole load of things, it's too much for us to embrace, and we will die out. You know, it's not because we don't want, but the passion dies because we are not in this kind of research. We are not that brainy. Yeah. So what we can only do is we can only do that one. But you know, for sure, you know, Dr. Audrey, printing t-shirt is not part of it. We don't do that. But we want to do the continuation. I think you pointed out something that is very, very important. It is a long-term kind of thing.
Yes.
And I saw in the mangrove that I was in, there's lots of people who put their banners and all that, you know, it's until it's already all rotted, you can hardly see the painting, but it is still, you know, half dangling there. So I think those are the one time off, but we want to make sure that we don't become one of them. But we need to have continuous encouragement, I would say, that to tell us sometimes that, hey, you know, you've been doing a good job, continue to do what you do, but can you do a little bit more? So this way we are guided. If you're not guided, forever I'm digging and planting. Now today you tell me that I have to measure after how long I planted, how much did it grow. You see, today I learned. And we need that kind of guidance. And I was just wondering, from the perspective, I just have one question. If let's say we do whatever we do, we must have a certain outcome, right? So how can I leverage on the research professionals like you guys on what impact did my nursery do? From the time that I invested my time here, right up to here, I have planted, say, 2,000 mangroves, and I have gotten this kind of records and all that. So what impact did I do? Did I make any impact or not? How can I leverage? I don't know how to calculate all that. My engineer also said, hey, I am not from the agriculture, you know. So where can I seek this kind of assistance? Thank you.
You want to go first?
Sure, Dr. Audrey. So, Miss May, this planting thing, it's a long-term commitment, and I think I have to congratulate Top Glove for doing a wonderful job. You guys are engaging the community, the area there in Taman Rekreasi. A lot of things are being put there. Even I'm also sharing some of your site to place some of my seedlings. Thank you so much. But once you have planted, probably you could see the benefit, the impacts of it once the tree has reached a certain age. Let's say we want to look at the point of carbon stocks. We can't do that now because the saplings that you have planted is very young. So maybe another 10 years or so, only then you can actually look at the impact. But when we are planting saplings at the young age, it will be difficult for us to say that, look, we have planted the saplings, it's going to create a natural barrier in X number of years, in a short term of time. We have to be and journey with those saplings that you have planted in order to see the soil formation which going to take place, the whatever species that you have planted there. Hey, look, there are some faunal communities where it was not there before this, that you have to look at it, and that flora and faunal part where how it can actually enrich the areas that you have planted. So this is my comment on that. Maybe Dr. Aldri would have more to add in.
Yes, if I may respond to your question, May. So, but don't be afraid if you hear this. No, I don't want to demotivate you, but this is the importance of Dr. Jeyanny's earlier point of synergy. So yes, we understand that. Even I myself, I focus, or I specialize more on forest or plant dynamic, or mangrove plant forest dynamics. So I cannot say I'm an expert in soil, and this is why I invited Dr. Jeyanny to tell or to teach me about the soil angle about mangrove. So working together is the key here. So to answer your worriness just now, yes, I mean, like we know of your responsibility. Of course, you push, you contribute to economic development through businesses, and you have that awareness of assisting or contributing back to protecting environment. So that's good already. But then how you do it is another step in which I mean, I appreciate so much your attendance to this seminar. That shows the commitment already, and this initiates I mean, an interaction, and triggers perhaps now a next step would be collaboration. So you have academic and research, the scientific team to assist you already. But another two stakeholders, if you like, that would need to be in this network of relationship or friendship would be first state authority or land owner, I would say. So target that area, and we must take into account the land tenureship or land ownership of that particular area. If it's a forest reserve, forestry department must be involved. They must know of what's going on and interact with them. And if it's other state authorities, for example, that own the land, they have to be in check also, in the know of what our plans are. And this actually, the bad example, I mean, one example would be like, for example, local communities working or working very hard, planting an area, restoring an area. Apparently that area was earmarked like 15 years ago for development already. So it's either working with them to change that plan, or to just make sure the efforts are not put into waste. So that's how we strategize. So that's why planning is very important, like what pointed out by Dr. Jeyanny. And I already pointed to you the fourth stakeholder, the local community. So if you do work in for example, Klang or in Sijangkang or in Kapar, this is Selangor alone. Imagine throughout the country, from like I said, Langkawi to Sabah. So make sure that they are part of the synergy as well. So we, the scientific community, can help on the scientific part. The government approves or in the know, that would help in the long term. So to make sure that that area will be forested, will be a mangrove again or something like that. And local communities, don't ever neglect them because they live there for generations. They know that area way better than any of the three other stakeholders, key stakeholders, and perhaps they can be the eye and ears. So you cannot go and check tomorrow, the next day, or the next month, the next week, or the next year. So they should be there. And this is how all of us scientists actually now, transforming or working with communities to promote citizen science, and in which we have, you should consider also in your corporate CSR project of having some kind of portion to train this community. Bear in mind, this is from our experience also, me, Jeyanny is similar. Not, when we speak about community knowing their area, not necessarily. So there are experiences like communities knowing very generally about their habitat, but not specifically. For example, like what species to plant. They may know rhizophora in general, bakau in general, but maybe not the specific hybrids, for example, or specific species localized in that plot, for example. So there you go. I mean, we need to learn from the community. Community needs also to be very resilient or responsive, if you like, to our inputs as well. But no dominating. I mean, work in a nice synergy of all four stakeholders. I think that's the best formula ever for mangrove restoration. And I agree. I take note of your points. May, not just you. I reckon this applies to all corporate and private organizations. They need guides. So this is my suggestion earlier to Dr. Jeyanny and my team actually, and the MyMangrove team. I mean, like, we have to come up with like a, a guide or a manual to assist corporate organizations to do solid planning for planting in the short, medium, and long term. Yeah. So I take note of that. Hopefully, the Jeyanny free sometime in December, where I will try to gather all of you, my mangrove speakers this year, my mangrove speakers in 2019, and the rest of the MyMangrove network, to perhaps contribute to constructing or building this a lot of plans actually I have in mind. So that would be one of the key. I think now it's urgent for me, so we will try to work for it or to prioritize that. Yeah, hopefully soon. Of course, there are some brief guideline already, but then yeah, specific for Malaysia we haven't got any. So let's work on it. Yeah. Okay. So thank you again, May, and please stay with us for the rest of our activities, and I will later highlight of our of how for the rest of the corporate organizations, corporate companies, and community at large to be part of us as well. Yeah. Okay. So the discussion is getting hotter, Dr. Jeyanny. Amazing. Contributions from the crowd here. So I think maybe we can take another one or two, yeah, Dr. Jeyanny, before we end. So okay, or maybe three. Okay, the third. Okay, the final one, and the third last one would be from Fu. I think I don't understand this. Other 620,000 hectares gazetted. Oh, I think this refers to the total area of mangrove forest done by Dr. Hamdana. Okay, do you want to respond to that? And what is the average carbon sequestered in the bakau tree compared to deep throat cup? Okay, if you want to answer that.
I've actually given the answer in the chat itself, Dr. Aldri.
Oh, so, you did? Okay. All right.
Yeah, so it's because these are estimated using GIS methods, you see. So some are gazetted by the forestry department and some are not, unfortunately. So to get the right figure, which is fully gazetted, and I don't have the figure, I know it would be from the forestry department statistics. Correct. Yeah, the carbon stocks is quite substantial. It's usually more than 500 to 600 megagram carbon per hectare. I think Dr. Aldri would agree with me also. So in lowland Dipterocarp, based on my work that I've done, it's about 100 to 300. Depending, 300 is already quite high.
This is new information to me too. Actually, this is my, something with me. I think maybe my weakness, numbers. I cannot like really memorize numbers well, especially. But then yeah, briefly, yes. I mean, this could be the range of which this is why mangrove is established as the the most powerful habitat and ecosystem to sequester carbon. That
So
alone, that example alone, Dr. Jeyanny has already like showed the wide difference in between lowland carp, and I think maybe the 300 one could be in between, maybe from a peat swamp and peat swamp and mangrove forest is I mean may have similar range of amount of carbon being stored as well.
So the values that I gave was actually more on above ground, Dr. Aldri. So we are not talking about the soil.
Not yet, there you go.
So we have 5 components in carbon, don't forget. So the highest component are usually in the soil and the above ground. So even in soil, it could range quite high, so that's why usually I try to take samples up to 1 meter depth in order to see how much with that, different horizon, it can actually store carbon. So that is the thing.
Yeah, I missed that one. Yeah, you're correct. Thank you for highlighting that. So this is just above ground. Imagine above ground already, that wide gap. So what's happening in the soil is another issue, and we all know already. I mean, roughly, that I think 70-80% of the total carbon actually come from the soil, the stored in the soil. So there you go. That's a range we are looking at, Fu. And the 620K, yes, according to Dr. Hamdan's report, that's the total area of mangrove cover for Peninsula, Sabah, Sarawak, total up to 620K, and the figure showed earlier by Dr. Jeyanny was the map of the percentage of mangrove according to states. And of course, we know, I mean, nature habitat like mangrove, they don't know borders, they don't know boundaries, right? So we take it as a whole. But then roughly, if I can note, I think there are representatives from Forestry Department too here. I think Cik Jamal, our regular participants here is here to maybe verify. So out of this 620, I think the one gazetted as forest reserve is around 500 to 520,000 hectares, and then the rest could be protected or conserved through state measures. For example, like Johor State Park, Johor National Park, Johor State National Park, or maybe Setiu wetlands, yes, the Setiu State Park. So some portion within Setiu is mangrove area. So this is how mangrove being protected. Also, don't forget, under the Fisheries Act, some mangrove actually are located within marine parks and marine reserve. So and then the Sabah and Sarawak, they have several categories of protection as well. So yes, I think that's a very good. Actually, I've whispered to Dr. Hamdan in our January edition of MyMangrove Monthly Discourse to do that. I mean, let's carry out that analysis, meaning we know already the total area cover. So why not overlay with areas being protected already? So that way we can straight away, I mean, easily we can identify unprotected area and perhaps earmark them. I mean, and study that to identify also restorable area. So that also will help me to identify her targeted area to help, right? So we don't simply like plant anywhere, everywhere. So we do it with strong support of scientific suggestions. So that way could be another way to go. And then, okay, there you go. I think I answered that question of Fu. He asked any further action to gazette other mangrove sites. Yeah, there you go. So if we know, I mean, the changes, I mean, the difference of the mapping activity, then we can assist or recommend or suggest to the state authorities to protect the rest of the area. Yeah. FRIM is working with the ministry relevant. Oh, okay, that's your point. Okay. All right. So I think that's the last of the question. Yeah. Oh, again, from Fu, yeah, would at least the site at Perak or Johor Gazetted. Yeah, that's right. So In Perak and Johor is quite significant area of mangrove has been gazetted lah. Johor, Sungai Pulai is a forest reserve as well as a Ramsar site. Tanjung Piai and Pulau Kukuk, for example, are Johor State National Park, and they are also Ramsar sites. And there are forest reserve like Sungai Lebam, Sungai Johor, but then there are small patches that actually need some help. So we are whispering to the state government. I actually spotted like a few 20 to 25 spots within Johor that actually need some further help to be protected. Yeah? And finally, okay, I think I can accept this. Dr. Rozaimi appointed another key question for blue carbon science relates to the colonization history of the vegetation. Something not easy to do, but very important nonetheless. Yes, thank you, Dr. Rozaimi, for joining us. And I think that's a very good advice for us to take note. Yeah. So I reckon we have reached 40 minutes past 4. That's a very quite
long discussion.
Good discussion. Yeah, thank you very much.
That means everyone has been listening to my talk, not sleeping. Thank you so
exactly.
much.
Yeah, that's a good indicator. So indicator criteria in indicator. I think that also is a important point to answer May's earlier question. So we will maybe develop this kind of guide with criteria and indicators, and perhaps to help them identify their end game. Yeah, end game meaning of what to achieve in a restoration activity or restoration or in the planning of restoring an habitat. Yeah, you may, and I reckon the key word there would be ecosystem services. So you look at the success from the ecological standpoint, but also considering the economic and social needs, yeah, especially on their cultural role. Yeah, the ecosystem services, there are regulating roles, provisioning roles, and also cultural roles. And also the more important one is them as a habitat, to provide supporting roles for all of these key ecosystem services. Yeah, so I reckon that's it. Yeah, for today and for the June edition of the MyMangrove Monthly Discourse. And I just want to share again Dr. Jeyanny's a pretty picture there and the abstract. So again, I would like to thank all of you for joining. And then, And then, as we planned, in July, we will have Professor Moritz Muller from Swinburne University of Technology in Sarawak to share with us, to discuss with us on microplastics, on plastic pollution and microplastic in mangrove environment. So stay tuned for that, and you can already see also some prominent names there. Dr. Siti Aisha, Dr. Rozaimi, Dr. Louisa, and Dr. Azlin will follow in the rest. Through the rest of the year. And before, there you go, Dr. Jeyanny. December, I've already reserved that for us to come up with some plans and perhaps also discuss about outputs and outcomes, and maybe response from all comments and discussion from January until November. Yeah. And to finally to add on to our response to me just now, this is the network. This is a platform actually used for the network. So get involved. Yeah, add yourself to the Malaysian Mangrove Research Alliance and Network MyMangrove Facebook group. So we currently have 2.3k people within our network. So and this out of 2.3k, I think about maybe 1% are scientists, yeah? And the rest are actually mangrove fans. So I would say corporate organization, government staff, government authorities, communities. That's one of the key component that contributes to the success of this network so far. Yeah. So add yourself. You don't have to add me or Dr. Jeyanny as your friend. It's okay. But you can be part of this and contribute to the discussion. Ask question if you need, specifically for locations, for example, you can come from anywhere, any part of Malaysia, and you will be surprised that actually this network also involve all of our friends throughout the tropics and throughout the world. So there are scientists from other parts of from outside Malaysia that can also contribute very significantly to your question and to our issues, to issues concerning mangroves in Malaysia. So with that, I mean, my final request, I see Dr. Jeyanny already turning off her camera, but may I request for, I mean the participants today to actually turn on your mic for just 30 seconds to 1 minute as a proof of attendance.
The video,
the video,
camera,
sorry,
camera, not mic.
Camera, right. Yeah, so if you can turn on your camera for just 30 seconds for one moment for us to capture, so we can.
A lot of familiar faces. Nice to
so
see.
Dr. Jeyanny can frame it in her room, in her office. Yeah. And thank you again. Puan Aslinda, how are you? Yes, this is another key person contributing to the study on hydrology. And Puan Nur Aslinda actually was one of our speakers in the 2019 edition. Yeah? And Dr. We see Dr. Harinder, Dr. Maiza, and Alison was one of our previous speakers as well in the international seminar series. So thank you again for joining. I see some industry player like Ho An. Thank you for joining. Yeah, and Fu again. Thank you for your question. And Stephanie, representing Malaysian Nature Society. I reckon she's the vice president. No, you're the secretary general, right, of the MNS. I think she's. Your mic is off. Yeah.
Yeah, I was.
You were.
Yeah, and then the vice president.
Thank you very much for the support for this seminar. Okay, if I may capture the picture now.
Dr. Aldri.
Yes.
We also have students from UMT, my class.
Oh, thank you very much. Yeah. Okay,
Thank you, Dr. Maiza, for joining.
Yeah, so I mean, when Dr. Maiza suggested to me that to turn this event also as an industry collaboration in between her course and the seminar, I say yes, it's a good goal. And the rest, thank you for joining again. Yeah, so 1, 2, 3. San. Una muna renda. All right. So thank you very much, everyone, again for participating. Oh, new camera. Hold on. I just saw Alison and a couple more students just now. Okay, 1, 2, 3. Oh. 1, 2, 3. I forgot. I use Mandarin and Tamil. I miss Bahasa Malaysia. Anyway, okay. So again, thank you very much, everyone. And again, to respond, you can catch up if you miss or late. I mean, if you entered late just now, you can always check the seminar on our YouTube channel. Yeah? So until next month, happy mangroving and take care. Thank you. Bye-bye.
Thank you. Thanks, everyone. Bye.
Thank you. Bye.